So, two spheres of equal mass collide along a shared I-axis. Their speeds are u and 3u in opposite horizontal directions. Both spheres collide at an angle alpha to the horizontal. Given that e is 2/3, find, firstly, the velocity of the faster sphere after colliding, and secondly, the magnitude of the angle beta the slower sphere is deflected through as a result of the collision in terms of alpha. Now, there are a lot of words in that, so it takes a while to dissect oblique collision questions, so go ahead and try this if you want, or you can come back and see the problem-solving strategy for oblique collisions. So here's a little diagram of what's going on. Now, this should actually, it's cut off slightly here, but that should read that e is 2/3. So here's our little diagram. So we have our initial velocity of the slower sphere as u cos alpha times I plus u sine alpha times j. And the other one is minus 3u, so we actually get minus 3u cos alpha I plus 3u sine alpha j. Now, since it's colliding along this axis here, it will be deflected somewhere over here. Because the coefficient of restitution is sufficient enough, it will probably bounce out this way. Sometimes it will actually bounce something like this, so through an angle beta here. But in a lot of the scenarios with coefficient of restitution greater than 1/2, a lot of the time you'll be dealing with ones that travel what's known as outboard with the horizontal or with the vertical. So firstly, we do conservation of linear momentum. We get mu cos alpha plus m times minus 3u cos alpha, minus because it's the vector, is mv1 plus mv2. So cancelling the m's and simplifying, we get v1 plus v2 is minus 2u cos alpha. And that's our first equation. Now going over to here, we have Newton's law of restitution, which is v1 minus v2 is minus e times u1 minus u2. So that's 4u cos alpha. So minus 2/3 times 4u cos alpha is naturally minus 8/3 u cos alpha. And multiplying across by 3 to get it in a nice variant, we get 3v1 minus 3v2 is minus 8u cos alpha. So after simplifying, we get that, or if we multiply this one by 3 and solve simultaneously, we get v1 is minus 7/3 u cos alpha. v2, we can actually work from either one of these, we can work from here. So if we add v2 and add 8/3 u cos alpha, so we get v1 is v2 minus 8/3 u cos alpha, and then add 8/3 u cos alpha, we get this relationship here, which gives that v2 is 1/3 u cos alpha. So v1 we're given as this one, so this is given as u1 as well. As you can see, it's minus 7/3, so it is actually traveling outboard. So the velocity therefore is 1/3 u cos alpha I plus 3u sine alpha j for this one. But for here, we have, or this is actually the answer for part 1. Part 2 is down here. So u sine alpha is the vertical component, as I've drawn here. The horizontal component is 7/3 u cos alpha. So cancelling the u's and applying some trigonometric laws and some fractional laws as well, we get tan beta is 3 tan alpha over 7, or it can be written simply as 3/7 tan alpha. So if given the initial angle, we can find the angle at which it is deflected in this particular case.